Is it possible to calculate the dioptres, so the optical power of your glasses at home? Well, yes it is, and here's how. Each pair of glasses comes with two lenses, and these lenses work as follows. So if there's an object sending out light on one side of the lens, then these many beams of light are focused by the lens on the other side, in a certain point, which then is called the image. We call this distance the object distance, and that distance the image distance. And then there's a quite simple equation which is called the lens equation, which tells us that 1 over the focal length of the lens is equal to 1 over the object distance plus 1 over the image distance. And now, per definition, the optical power, so the dioptres of your lens, is equal to 1 over the focal length of the lens. So in the end, we get the optical power equals 1 over the object distance plus 1 over the image distance. So if I can somehow measure the optical distance and the image distance of my glasses, of my lens, then I can automatically and without any problems calculate my dioptres. And this is done as follows, for example. My blinds are currently closed, so the only source of light I have at the moment are the light bulbs at the top of my room. I can now take my glasses and hold them above the table, and as you can see, the shadows which my glasses make are quite interesting. For example, the right shadow is much thicker than the left shadow, which is because my right glass is obviously stronger than the left one. And now, which is the interesting part, there's a certain distance where this bright area in the right shadow converges to a single point. And this is the focal distance I was looking for. So at this specific distance, we have exactly what we've drawn before. There's the light bulb at the top of the room, and the table at the bottom obviously, and the lens in between. And now the light from the light bulb is coming and is focused by the lens into one single point on the table. So what we need to do now is measure the distance between the lens and the table, and between the lens and the top of my room. Okay, so I'm trying again to let the point converge, and I think that might be the optimal height. And I've marked this height with the lamp on my table so I can measure it now. Turns out the distance between the lamp or the lens and the table, so the image distance, is roughly 37 centimeters. And the distance between the lens and the top of my room, so the object distance, is roughly 140. Okay, so let's now plug in our results into our lens equation. So our dioptres, our optical power, equals 1 over the object distance, which is 1 over 1 meter 40, plus 1 over the image distance, which is 1 over 0.37 meters. And this gives us something roughly about 3.4 dioptres, which is quite good actually, because, let me check. Okay, so according to my papers, my glasses have exactly 3.75 dioptres, which is quite good, I think, because considering that was a homemade experiment with many light bulbs shining onto my glasses, not only one, and also many other measuring inaccuracies, that result is quite satisfying if you ask me. So off you go, calculate your optical powers of your glasses and checking if your optician's done their jobs correctly. And if you have any questions or recommendations for upcoming videos, please put them in the comments. And if you have been, thanks for watching.